kind of three takeaway points from yesterday. We want to use complex numbers to solve equations, and in order to do that, we had to introduce our imaginary unit, right? But that was an imaginary unit, and that was a part of our definition of complex numbers. When we refer to complex numbers, in a general sense, right, we generally say let z, where z is some complex number, equal to x plus yi. Okay, now remember, x and y, they're actually real numbers, yeah? And when I'm talking about the real part of z, what am I talking about? X, yep. And I add an imaginary number, but if I'm talking about the imaginary part of z, I'm just talking about the coefficient in some sense. Yeah? I'm talking about the value that's multiplied by I. Right? The last thing that we won't go into too depth much at the moment, right? But just to give you a visual sense of what's going on, is I said to think about where these numbers can coexist with the numbers we have already, right? If these are our real numbers, right, where do our imaginary numbers fit in? I said that they fit inside, well, they don't really fit inside. They exist beyond, right? And in order to do this, we construct another axis to represent this. Yeah. And why does this make sense? Well, what was the reason I said this actually kind of makes sense in some sense? Yeah, right, because when you multiply by piles of I, you're getting iterations of 4, they repeat itself, right? And that fits perfectly in line with this idea of multiplying by I being some kind of rotation around, right? If we think about multiplying by -1 rotates 180 degrees, if you multiply by I, you're kind of going halfway in some sense, which is naturally creating this axis here. This is something called the Argand diagram. We're going to park that for a moment. We're going to explore that a bit later on. But I just want to talk about what you've actually done here. We've created a new number system, or we've expanded the number system. And that's really important because we take it for granted. But anytime you do that, you're actually meant to define rules for that. For the real numbers that we have, even just for like simple counting numbers, there are actually rules, or mathematically we call them axioms, right? I just printed off a list here. There's actually like 12 axioms for numbers, right? Just adding up, multiplying, dividing, right? And if you were to introduce this to a, I don't know, year 1 or kindergarten student, like what do you think their reaction would be if I said, hey, this is how we do it? Yeah, they'd be like, okay, I have no idea what you're talking about. Like, that's messed up, right? Like, what is this? And the reason why we don't do that is because if you think about adding and subtracting, you can naturally think about that. It's just like your fingers or something, right? That presents a problem, though, when we expand the number system, right? What was the first kind of expansion to the number system that we looked at? Like, you have the counting numbers, and then you look at fractions, right? Which a lot of students have an aversion towards. And I suspect a part of that is because it doesn't really fit in with their own definitions of the rules for numbers. Like, as an example, half plus 3 on 4, what's a really common mistake that students make or something like this? Right, like, think about your axioms for addition. We add numbers, okay? I'm going to add numbers. 1 plus 3 is 4, 2 plus 4 is 6. Yeah, easy, right? 4 and 6. And you can't blame... they can't be blamed in some sense, right? Because that fits in with what they know already, okay? So we know that's all right. But something a bit more recent for you guys, like what about these guys? When we have surds, again, common mistakes that someone might make are, oh yeah, we just do that, yeah? And again, it's because we have these predisposed ideas of what addition actually is, and we apply this to our new number system. And so what I want to do first today is I want to define the new rules when we use arithmetic with complex numbers.